Hi, good morning, everybody. Am I audible?
Yes, sir. Yes.
Okay, I'm sharing my screen. Once you're able to see the presentation, say yes in chat box. Yeah, okay. Okay, thanks, Srinivas. So yesterday we have covered boiler safety in IS 103, and today we are starting with IS 104. So the IS 104, the paper title is Quality Control in Occupational Safety, Health and Environment. That is the title of the paper, which is fourth paper in this curriculum. So the today's topic is hazard identification. So anybody can give example of hazard in chat box. So we'll continue. What is mean by hazard? Any one example, simple example. Okay. The work at height. Yes, work at height. I mean, it is not a direct example for hazard. Working at height without any safety uh, precautions. Okay, hard work, yes, fall hazard. So basically, yes, hazard is nothing but it is an inherent property of a substance. Substance in the sense, maybe any form, either in solid, liquid, chemicals, or any other thing else, or unsafe condition, unsafe action or situation to cause harm. Because inherently it is having a nature, it can leads to an accident. Confined space without PTWS, snake hazard. Okay. Okay, basically it is a hazard is the inherent property of a substance or unsafe condition, unsafe action or situation. It can cause harm, which may cause human injury, damage to property, or the environment, or some of the combination of these criteria. So, for example, knife. The sharp edge is a hazard. Petrol, it is a fire hazard. But normally, the petrol looks so calm, it won't do anything. Once it is evaporated, if you put in open atmosphere, what will happen? It gets evaporated. It can create a vapor cloud. So it can be ignited in case of any the fire source or ignition source is available. So like that, we can take many hazards. For example, if you're riding a bike, a brake failure or over speeding, all these fall under the potential hazards. Even slippery surface or obstructions, tripping hazards, all these are, we can say, considered under hazardous situations. So basically, the chemical hazard is a hazard due to the chemical, including its storage, process handling, etc., and is realized by the fire, explosion, toxicity, and radiation. So chemically, it is a hazard. How it will be? Due to its nature. If you are not handling it properly, it is become a hazard. If you are not storing it properly, it is turned into a hazard. So storing in the sense you are not stored it under atmospheric conditions. They may say that you have to store under below room degree temperatures or below 25 degree or below 10 degree. If you're not storing it, it's get decomposes or it can react or it can change its chemical structure. Then it will become a hazard. Either it will result in a fire or explosion or toxicity or radiation. Then risk is a likelihood, chance or frequency or probability. How we can calculate the risk? Severity into probability. So when I say severity, the impact of that hazard, the result of the hazard, and probability, it is an occurrence frequency. How frequently it can happen. These all are assumptions. While doing risk assessment, we would have come across with all these three terms: hazard, then severity, and risk. So when I say hazard, if I assume a chemical, a fire hazard, so when I say severity, we'll define a number in the risk matrix. We used to have a 3 by 3 matrix or 5 by 5 matrix. In one side we have severity, and on the other side we have a probability. So when I say severity, if fire hazard happens, how its consequences will look? Either it is burning off the complete store area, or it is only limiting to that particular barrel, or it is taking off complete a factory. Then probability, how frequently it can happen. Frequently in the sense once in a while, or rarely, or very rarely. That is the probability. When I say severity, it is a multiplication of probability. Sorry, when I say risk, we can say risk equal to severity into probability. So here they have given example of risk is likelihood, chance, frequency, or probability of undesired event, that is accident, injury, or death occurring within a specified period or unspecified circumstances, and its severity, effect, or consequences. Severity is nothing but effect or the consequences, which means the result of an event, the result of an accident. For example, if you take a bike accident, every time it is not going to be severe. Sometimes survived by small sprains or scratches, abrasions. Sometimes we may survived by any small fractures, sometimes severe injuries. Sometimes it is fatal. In all these four cases, the severity is different. In first case, the severity will be, I can say, 1 to 4. The severity is 1. In second case, I'll take it 2. In third case, fracture, I'll take it 3. And the fatal case, I'll take it 4. When I say 4, the severity is very high. These all are assumptions when you are doing a risk assessment. So we assume with our practical experiences and our own experiences and past scenarios. Based on all these things, we'll make our risk assessments. When we say hazard, so there are again two types, the visible hazard and also invisible hazards. So anybody can give example of invisible hazards meanwhile. So when I say visible hazard can be detected by various techniques such as plant inspections based on statutory requirement, checklist, safety survey, safety audit, and safety sampling, and detection and monitoring systems, functional test of machinery and equipment, accident investigation, a repair shop, store consumption, and shop feedback. So these are the various options or areas we can look for a visible hazard. When I say visible hazard, we can able to see that. One is plant inspections. So if there is a hazard or slippery surface, something is blocking the vision, or the things are on walkways, those all are visible hazards. We can understand by plant inspections and statutory requirement. Statutory requirement, what is the, anybody can give an example? Inspection and statutory requirement.
Factory license.
And I have not received responses for invisible hazards as well. Just please put in chat box. Okay. Yeah. Then surveys and safety audits. We used to do different types of safety audits. The companies will have ISO 45001, occupational health and safety management systems. We do internal audits and external audits, etc. And detection and monitoring systems like fire detection systems or leak detection systems, etc. Then functional test of the machinery. We used to do the testing of an equipment. Okay. To check the condition of the equipment. That is also a physical risk. Then we can do accident investigations to identify the physical hazards as well. Even repair shops. Okay, that is also one technique we can understand. Even store consumption. So store consumption, for example, if the gaskets consumption is increased comparing with last year. So what does it mean? There are so many leaks would have happened in the pipeline. That's why the gaskets consumption is more. Maybe other way of thinking it, the gaskets, the quality is not so good. That's why we are frequently replacing it. And different way of looking at a scenario. Okay, uneven or incomplete foundation or structure. Yes, okay. Right scenario. Okay, very good. Poisonous gas presence in atmosphere. Okay, chlorine leak. Okay. Okay, good. Thanks. So when you say example of visible hazards, there are unguarded machinery, bad housekeeping, wrong practices, to discover such hazards, we need to have careful planning. Inspecting systems is necessary. We'll see some of those. One is make a list of statutory applicable provisions of Factories Act and other acts, and make a survey of plan to compare the existing provisions and also find out the missing provisions and for implementation. So we have to make one checklist where we can create or where we can list out all the statutory requirements. For example, lifting tools and tackles, that is a statutory inspection. A pressure vessels, UT, that is a statutory requirement. Then safety relief valves, that is a statutory requirement. Noise, that is a statutory requirement. Very good. Then illumination, that is a statutory requirement. Then water analysis, that is also a statutory requirement. We have to list out all these things, and in case of any gaps we have identified, we can put in. One second. Then second, make a list of materials, processes, operations, vessels, equipment, machinery, and classify them as hazardous and non-hazardous. Chemicals should be classified according to their hazardous properties. First case, we are thinking about the legal requirements. And second case, we are making a list of materials. What are the different types of materials we are using in our process? And also as an auxiliary consumptions. It is not about only the direct process raw materials. It is all about also auxiliary consumptions like grease or oils, etc., we use in our processes. Okay, that is also one requirement. Then we have to see the processes and operations, vessels, equipments, and machinery. So we have to list out these all the categories, and we have to divide them into two major area. One is hazardous ones and non-hazardous. Then chemicals. If you're using any chemicals in your process, you should classify them as based on your hazardous properties. We have a UN classification of chemicals, 9 chemicals. There are flammable liquids or flammable solids or flammable gases. Then oxidizers, radioactives, explosives, poisonous, toxic, miscellaneous. So like that, we have to identify. So the chemicals which are fall under which type of property, then properly we have to store them. Then prepare a layout of a plant, machinery, equipment, premises, and utility services like power, water, air, and gas. So we have to have a layout so that we can understand in case of any emergency where it has happened and with what type of equipments which are present over there. And accordingly, we can take necessary actions. Then invisible hazards. So what are the invisible hazards? So as our colleagues mentioned, a gas leak, a concentration of toxic and hazardous vapors, malfunction or failure of machinery, equipment, pressure plants, miscellaneous or environmental factors. So even pressure plant also, it is invisible until unless it will explode. Before explosion, we can't see anything. Again, I'll take a general example of a pressure cooker inside our home. Till the time it will explode, it will just in a cooking ware we are using for it. Once it explodes, then only we'll understand, okay, something went wrong inside. Okay. And when other environmental factors may cause sudden accident or heavy damage, they must be detected and controlled by a built-in self-corrective systems The device uses are detectors, recorders, alarms, trips, probes, sensors, limit switches, meters, analyzers, electronic or auto controls, scrubbers or incinerators. These are the different types of devices we use to control these invisible hazards, or it is not about complete control. Sometimes it can alert us. Yes, there is a pressure buildup is happening, especially for the exothermic reactions. So exothermic reaction, what will happen? The reaction rate increases 10 times than the existing state. Then it can release uncontrollable heat. So what we do? So it can give us an indication the temperature is rising up so fast. Immediately, we will supply in the jackets, we'll supply in a cool water or something else, etc. So we cool down the temperature of the mother liquor, which is nothing but the chemical. Then we use alarms and trips. These are very common. Then sensors and limit switches, meters, analyzers, etc., etc. In modern machines, various automatic movements takes place near and around of the operation. A feeding devices, a clamping action also, workhead movements should be interlocked with each other. So it is about the equipment movement where a human can intervene. So horizontally moving machines, a person may enter inside a machine to do some setup without thinking of this movement of an equipment. They may caught in between. Each position of these elements must be sensed and also linked with command controls. Any malfunction of moving elements is indicated auto visual panel and also a machine stops. So that's where we come with sensors or detectors. In case of anyone intervene in between this path, immediately the machine gets stops. And repair shop data reveals the clues to unsafe conditions like poor design, defective material, poor construction, wear and tear, etc. And repetitive repairs indicate major hazards. Similarly, store consumption data also indicates some defects. So repair shop also gives us enormous information. So what this accident leads to, because of the quality of the material, because of the condition, or the is in a design defect or material defect. There should be a regular feedback of the information from repair shop, stores, and operations for many to monitor hazards and to take corrective actions. So it is very important that as in a safety. So once if you are met with any accident, not you, I mean any incident happens in our facility, we should not stick with only the investigation with the exact location. We should also take feedbacks from maintenance teams and also workshop as well, in case of any equipment or in case of any tools or in case of any machinery involved in such accidents. So that because they are the repairing those machines and equipments, they can understand what went wrong. Then we can accordingly take proper corrective actions. Okay. Now we'll see risk analysis and assessment and management. So basically, the procedure of risk management is like 5 steps. One is look for hazards, then decide who might be harmed and how, and evaluate the risk, decide whether the existing precautions are adequate or whether more should be done, record your findings, review your assessment, and revise if it is necessary. If I see in our regular practical scenarios, basically in our risk assessments, what we'll have, first we'll take the name of the activity, list of hazards, who might harm. In that, we'll write employees, contractors, visitors, etc. Then to the what extent it will not be there. Then we'll have severity, then we'll have probability, then we'll calculate risk of that activity, then we'll have existing controls, then we'll calculate the residual risk, then we'll have the gaps. Okay, sure, Ganesh. So basically, this is how we do the risk assessment. Okay. Initially, we'll name it the type of activity. I mean, what are the activities we are doing? ఏమేమి activities చేస్తున్నాము. Then type of hazards అంటే అందులో ఉండే ప్రమాదాలు. Then who might get risk అంటే ఎవరెవరు ఆ ప్రమాదానికి గురయ్యే ఛాన్సెస్ ఉన్నాయి, అవకాశాలు ఉన్నాయి. Then how frequently it will happen అంటే ఎన్నిసార్లు జరిగే ఛాన్స్ ఉంది, ఒకవేళ జరిగితే దాని యొక్క తీవ్రత అనేది ఎలా ఉంటుంది, దాంతో పాటుగా మనము అక్కడ ఉండే రిస్క్ ని క్యాలిక్యులేట్ చేసి తర్వాత ఎగ్జిస్టింగ్ కంట్రోల్స్ అంటే ప్రజెంట్ ఉన్న సిచ్యువేషన్ లో మనకి సేఫ్టీ కంట్రోల్స్ ఏమేమి ఉన్నాయి, సో దాని తర్వాత మనకేమన్నా రెసిడ్యువల్ రిస్క్ అంటే ఇంకేమన్నా రిస్క్ బ్యాలెన్స్ ఉందా, అంటే కంట్రోల్స్ అన్ని ఉన్న తర్వాత కొన్నిసార్లు ఉండకపోవచ్చు, కొన్నిసార్లు స్టిల్ దర్ ఇస్ ఎన్ రెసిడ్యువల్ రిస్క్ అంటే ఇంకా కొంచెం గ్యాప్స్ ఉండటం వల్ల ప్రమాదాలు జరిగే అవకాశం ఉండొచ్చు. సో దాన్ని కూడా మనం అసెస్ చేస్తాము. ఓకే, హియర్ ఆల్సో సేమ్. బేసికలీ ఫస్ట్ we look for hazards, then decide who are going to be get injured, then we'll evaluate the risk, then record your findings. That is where record your findings in the sense risk assessment records. Then review your assessments. When we review on yearly. We'll review in case of any equipment changes or machinery changes, or we'll review in case of any accident happens, or we'll review in case of any process change happens. These are the various situations we'll review our risk assessment. One is ఎప్పుడైనా ప్రాసెస్ లో చేంజ్ వచ్చినప్పుడు, మెటీరియల్స్ ఏమైనా చేంజ్ వచ్చినప్పుడు, ఎక్విప్మెంట్స్ ఏమైనా మారినప్పుడు, ఏదైనా ప్రమాదాలు జరిగినప్పుడు, లేదంటే ప్రాసెస్ అప్గ్రేడేషన్ చేసినప్పుడు. సో ఇలాంటి కేసులలో there are a number of cases, but these are the basic cases. We'll do a review of our risk assessments. So as we see in the 5 steps as per the defined risk assessment methodology, there are qualitative and quantitative risk assessments. Again, qualitative, quantitative. I'll give a simple example. When I say quantitative, you are able to quantify. Quantify in the sense you can able to give the result in numbers. When we say risk matrix, so we'll give two types of quantification. One is qualitative, which is low hazard, a moderate hazard, high hazard. Then in the quantification, we say 0 to 5 is a low hazard, or 5 to 15 is moderate, 15 to 25 is a high hazard. When you say quantification, you are able to quantify the risk. That is qualitative and quantitative. When we see differentiation these two, identification of sources of hazards and their causes, it is a qualitative, which is hazard. And the step is known as hazard identification. When we say analyze mechanism of hazard occurrence and also the terminal consequence of hazards, this is a quantitative. The hazard, the consequences analysis quantifies the concentration, death, injuries, damage. Example, damage, distance, and effect. That is quantitative, where you are able to quantify number of deaths. Okay, 10 people have died, or 15 people are injured, or 1 lakh damage happened, like that. Okay, that is quantification. When I say probability, as I mentioned, it is frequency or likelihood of hazard occurring, and then an estimation of risk. This is also a quantitative, as it depends on failure rates and number of chances. It is also probability also we can consider as quantitative, because probability we are giving number. Okay, every 1,000 hours there is a chance of one failure. And judgment and acceptability of risk against legal, social, and political criteria. It is the risk analysis. Okay. Now we'll see a quantitative. Therefore, the decision making and taking control measures to prevent, reduce, transfer the risk by short and long term planning. This is a mixture of qualitative and quantitative criteria. And also, this step is known as risk management. When you are taking appropriate measures, when I say risk management, a risk or safety manager should assist the top management in this regards. So once you have identified the risk, so how you are going to control that risk? What are the measures you are going to implement based on your risk assessment? Once you risk assessment చేసిన తర్వాత we will identify the gaps. అంటే ఏవైతే gaps ఉన్నాయి, ఇంకేమన్నా additional safety requirements or additional controls requirement ఏమైనా ఉందా? When it is an additional control requirement, we'll suggest those additional control requirements. Then we will suggest the management. Yes, this is the risk level after our existing controls. And these are additional risk control measures required to control further or to avoid accidents. Okay. Now we'll see types or methods of risk assessment. One is simple or qualitative risk analysis. It is to identification of hazards and taking appropriate control measures, as we seen in the 5 steps we have seen in initially. And here the quantification of hazards and their terminal consequences like damage, distance, severity, and injury, loss, etc. are not worked out. So in qualitative, we are not seeing any quantitative numbers. We are not seeing how much distance or the severity of injury. It is sufficient to think about the adequacy of existing control measures, vice versa, the hazard identified, and to adopt more safety measures if necessary. Its important aspect is to consider the effect of control measures provided in place, and also think for residual risk and also residual control measures only. So it thinks about the existing controls are able to control the hazards or not. అంటే ఇక్కడ ఉన్న present గా ఉన్న కంట్రోల్ మెజర్స్ అనేవి ఏవేదైనా ప్రమాదం జరిగితే దాన్ని కంట్రోల్ చేయగలవా అన్న దాని గురించే చూస్తుంది. ఏది క్వాలిటేటివ్ రిస్క్ అనాలిసిస్. దాంతో పాటుగా ఇంకేమన్నా రెసిడ్యువల్ రిస్క్, అంటే ఉన్న కంట్రోల్స్ ని చూసుకొని ఇంకా ఏమన్నా బ్యాలెన్స్ రిస్క్ ఏమన్నా ఉందా, ఇంకేదైనా ప్రమాదాలు జరిగేదానికి ఛాన్స్ ఉందా, సో ఈ కంట్రోల్ బైపాస్ చేసి ఇంకేమన్నా ప్రమాదం జరగొచ్చా అన్న దాని గురించి మాత్రమే మాట్లాడుతుంది. ఇక్కడ ఎంత డ్యామేజ్ అవుతుంది, ఎంతమంది చనిపోవచ్చు, సో ఎంత మెటీరియల్ లాస్ అవుతుంది, ఎంత ప్రాపర్టీ డ్యామేజ్ అవుతుంది, దాని గురించి ఇక్కడ మాట్లాడడం అనేది జరగదు. When we say quantitative risk assessment, here the hazard potential is quantified. The possible risk is also determined if the failure data available and it is compared with a permissible standard. And this is indicate whether the calculated risk is lower or higher than the permissible limit. Based on this, a new control measures or modification in the existing controls can be decided. So basically you are quantifying the risk here. You are giving it in a numbers. Okay. So I'm stopping here for now. We have less than a minute. we can continue in the second session from this slide.